Hope my screen is visible.
Yes, miss.
Yeah. Okay. So today we're going to talk about the synchronous sequential circuits under that state assignment rules. Why do we require the state assignment rules first of all? See, initially we had just used the straight binary sequence. Just if I have say 000, I used to assign as A, 001, B, 10, C. Like this, I will do a binary assignment. But there is a requirement when you want to reduce the cost, you have to optimize the state assignment also. So based on that, we have some 3 guidelines / rules which are given for this state assignment. Okay, so we will go through the 3 rules quickly. Rule 1: 2 or more present states that have the same next state for a given input combination should be made adjacent. So what is the meaning of this? Say for example, I have state A. Okay, the next state for this is say BC. Okay, then say I have the state B something I have. Then say I have state C, say I have BC. So here, if you see state A and state C, both have the same next state. See, look here, 2 or more present states that have the same next state for a given input combination should be made adjacent. So here, you can make A and C as adjacent. Correct? Are you getting? So this is your state rule 1, state assignment rule 1. And here, if you just observe, for both the inputs, say on input 0 and on input 1, for both it has the same assignment. So we say 2x. That is, for both the inputs, it is the same. So you make A and C as adjacent. Okay. Next, I'll just simply explain this rules, and then we will take this example what you in your textbook was what he goes through, and we will talk about. Rule 2 is for any present state and 2 adjacent input combinations, the 2 next states should be made adjacent. So what is the meaning is, say from 1, say here, sorry, yeah, here say for example, you have from state A, B and C is the next state. So what rule 2 says is, you can make BC as the adjacent states. Okay, so B and C could be your state assignment. Clear? Now, what is this? See, for any present state and 2 adjacent input combinations, the 2 next states should be made adjacent. See, you have AB as the next state, so you can make B and C as the adjacent states. Then you have AG here. Okay, so for any present state, the present state here is B. For the present state here was A. So B and C can be made adjacent. Here AG is the next state. So you can make AG as the adjacent state. That is the meaning of your rule 2. Okay. And rule 3 is very simple. Say for example, you have the output on 0 and on 1. Okay. Say your output maybe 000101, something like that. Okay, so you can either consider the output which is 0 or which is 1. Okay, so usual practice, wherever your output is 1, we consider that So for which all the output is 1, you can even consider for 0, no problem. But 1 is more authentic. So those states should be made as the adjacent state. Okay. So wherever you have the input 1, I have input 1 for this, so B, and I have input 1 for this, so C. So I can make B and C as the adjacent states. So this is rule 3. This is rule 3. Or if you are considering 0 as the input, then you can make A and B and A and C as your adjacent states, because it is output is 0. Now, this is about your rules. You can see here 2 or more states that produce the same output symbol, that is 0 or 1, for a given input combination should be made adjacent. This rule need only be applied to one of the output symbols. Either you have to select 0 as your output symbol or 1 as your output symbol and make it. Okay. So this is about your rules. Hope this is clear to you. Now we will go here and apply the rules. Okay. Now, say rule 1. This is your table given to you. Rule 1, what it says is, as you all are aware, rule 1 says 2 or more present states that have the same next state for a given input combination should be made adjacent. Here, if you just go through here, you have AB for the first input. AB is not repeated anywhere. Next, check for BC. Is BC repeated anywhere? Yes. So B and C are repeated. So the state B and G could be made adjacent. So rule 1, B and G could be made adjacent, and for both the inputs it is the same. That is, for 0 it is B, for 1 it is C in both the combinations. So I'll say 2 times X, that is 2 inputs. That is the meaning. Next one, go through DE. Can you find DE elsewhere? No. Can you find FG? FG is here. Yeah, FG is here. Okay, in these 2 places. So which is that input? D and H. So DH should be the next, this one, and it is also appearing for both the inputs. Then if you just go through here, see, you can see D here, you can see D here, but this value is different. But still, you can make C and F as adjacent, but it will have less priority. It is only 1x. You need not mention if it is 1x. I'm just writing and showing you. Okay. CF also could be adjacent. Next one, if you go through like this, okay, anyone else, anything else we have left out? If you just see here, you have B and D. For one input, you have the same combination B and D. So, which is that state A and state F. So, AF also could be made adjacent, but only once it is appearing. Okay. Any doubts still here for rule 1? Hope you have understood. I assume you have understood. Next one is rule 2. Rule 2. What does rule 2 say? For any present state, that is, if I take any present state, say A, what is the combination? AB. So you can make, what is the next state? From A, it is going to AB on input 0 and 1 respectively. So it says you can make AB as the adjacent state. Okay. You can make AB as the adjacent state. And where all you can find AB, you can find only in this place. So it is appearing only once. So AB could be adjacent state. What do you mean by adjacent state? A could be your first state, then you can make B as your second state. But mind you one thing, rule 1 has the highest priority, then rule 2, then rule 3. And even in these rules, uh, which is appearing for more number of times, that is for more number of input combinations, will have higher priority. Okay. So now, so rule 2, I can make AB as adjacent. Next, BC is there. Is BC appearing elsewhere? Is BC appearing elsewhere? Yes, it is appearing 3 times if you can see. Shall I change the color? Yeah, 3 times. BC. See, this is CB, but still it is the same. So it is appearing thrice. So BC is appearing 3 times. Then DE. DE, is it appearing more than once? No, only once. So next will be DE. Next, it is FG. Is FG appearing? Yes, it is appearing twice. So you can write FG and it appears 2 times. Then which combination is left out? DH. DH is, you can make D and H as adjacent, but it is appearing only once. So it is a minimal priority. It does not take highest priority. So this is about your rule 1 and rule 2. Any doubts here? You can clarify if you have. Next one is rule 3. Rule 3, what it says is, two or more present states that produce the same output symbol, that is 0 or 1, can be made adjacent. This rule has to be applied for any one of the input symbols. Here, they have applied for 1 as the input symbol. See, 1 is appearing here, 1 is appearing here. This here, 1 is here. So you can make those combinations. See, 1 is here, 1 is here. So which are the states? D and F. So you can make that row, that is D and F, as adjacent. Next one is, here I have 1, here I have 1. So you can make, which is that row? E and G. So EG as your next adjacent, this one. Any doubts here? All the 3 rules we have applied here. Hope it is clear. Shall we move to the next concept?
Ma'am, is that FG or EG?
I'm sorry. It is EG only, no? See, here, sorry, 1 second. For third rule you're talking about. Third rule,
Got
right?
it, ma'am.
Yeah, this is E,
EF.
man. E. E, G. Here you have 1, na? Which row is that? E row. Here you have 1, 0. Okay, clear. Now, so that is what I have put here for your reference. You all can see. Then, if you just see this, you have one table, state assignment map for the state table of table 7.17a. Before we go to that, look here. You have this assignment. Okay. This assignment you have. A is 0, 0, 0. B is 0, 0, 1. C is 0, 1, 0. D is 0, 1, 1. E is 100, F and G. This is what? This is your straight binary sequence. Whatever table we had, na, A was 000. It is going to, this previous table is represented. That's all. Here, if you just see, A is what? 000. B is 001. C is 010. D is 011. E is 100. F is 10. G is 110. H is 111. So based on this, they have filled this. That's all. What is the next state? This will be 000. B is 001. This is 001. This is 010. D is 011. E is 100. Like that it is filled. This is that table, what you can see. Correct? This is clear to you all. This is the second table given in your book. Next one is the one where your state assignment is applied. Okay, where they have applied the state assignment. Now, if you just see this table, yeah, see what all we had as our state assignment. If you just see rule 1, rule 1, what all we had? We had BG 2 times, correct? Then we had DH 2 times. Then we had CF. Then we had AE. Okay. This was your rule 1. Then rule 2. Rule 2 is AB, BC. This we had 3 times, I think. 3x. Then DE, FG. This we had it twice. Then we had DH. Then comes your rule 3. In rule 3, we had picked for the output symbol 1. So you have DF and EG. Okay. Now, how to get this table? This is one confusion, right? So now to start off, actually you have BG with 2 inputs. I told you rule 1 gets the highest priority. But to start off, okay, you all know the meaning of adjacent. They can be vertically adjacent or they can be horizontally adjacent, or at the corners they could be adjacent. That is when you fold a sheet of paper. This and this are also adjacent, and this corner and this corner are also adjacent. This you all know from K-map. Now, to start off, because A is your first um, state, I've taken A as my first state. Okay. Say I have taken AE. That is in the rule 1, AE gets the first priority. Okay. AE. Then if you see what is adjacent to A, in this only AE was adjacent. Now I will move to rule 2. Here B is adjacent. Okay. B is adjacent. So A and B are adjacent if you see here, and here A and E are adjacent. Now we have to think of where to put, or shall I take one blank screen and show so that we can do it properly? Okay. Rule 1, rule 2, rule 3. As you all are aware, it is BG 2 times, then DH 2 times, then CF and AE. Okay. Then for this, you have AB, then you have BC 3 times, then you have DE, Then you have FG twice DH. So these are your adjacent states. Then for rule 3, we have DF and EG. Now, if you take your K map, okay. Now why I have taken 8 locations is because you have 8 combinations, correct? A to H, you have 8 combinations. Now where to place? So to initially start off, I have placed A. You may ask me why you have not placed E here. If you place E here, AE, then what is adjacent to E you have to see. DE. Can you place D there? If you please place D over there, then you have DF also. Will it be adjacent? That we have to check out. So initially, what I've done, because I'm starting with state A, okay, A is my initial state. For A, which is the adjacent state, E. If I place E here, you see the option. If I place E here, what is adjacent to E? D. Correct? So, if at all I have placed E here, if this is DE, okay, then with D I have F also. If I place F here, it becomes adjacent. Okay, but I have G. So, where can I place G? Say if I place G here, F and G. To G, which is adjacent, is E. He you have placed here. Correct. So if you place E here, for GE, this will not be adjacent. But if I place E over here, see, it is adjacent, or I can keep it here like this. Okay. So that is the decision how we have taken. Now we will see how to do this, how to fill this. So AB and AE. Now for B, which is adjacent, you see, for B, you have BG as adjacent and BC as adjacent. Correct? So you can make BC and BG as adjacent. If I place G here, what happens you see? If I place G here, I have FG. Where I have to place FG? For G, EG is adjacent. So instead, if I put G here, will it work out? So if I put G here, okay, you have a combination of EG also here. So that also is solved. So I have put it here. G is put over there. Then you have one more, BC. BC takes the highest priority, but it is under rule 2. But rule 1 has highest priority. So BC, C if I place here, what happens we have to check. What is adjacent to C? Apart from B, anything else which is adjacent, F is adjacent. Correct? So F, where can I place this F? If I place this C, to C which is adjacent, F. So if I place F here, CF. So now you check for F which is adjacent. For F, G is adjacent. For F, D is adjacent. Correct? So for F, see G is already here. So no problem. Now for F, D is adjacent. So if I put D here, D and F. Then now, which one is left out? See, H you have, DH. So H, if you place here, what happens you see? D and H are adjacent, correct? H can be placed here. Then, if you just see, F and G are adjacent. We will go on ticking, which is adjacent. D and H, done. B and G are adjacent, done. Then A and B are adjacent, done. Then A and E are adjacent. Then C and F are adjacent, correct? Then D and E, you check. D is here, E is here. They are also adjacent. With this placement of your states, see D and E is also adjacent. Then FG is also adjacent. Can you see here? F and G. Then DH is also adjacent. You can see here. FG is also adjacent. Then comes your EG. EG is here. E and G are also adjacent. Then DF. See here, D and F. They are also adjacent. Have we covered everything? Clear? So this is how you do the state um assignment map. Okay. Now you go back and check whether we have done it correctly. ABCH, you can see ABCH, EGFD. See? Clear? Now, based on this, you have your table 7.17C on page number 416. On page number 416. See, this was your table A 7.17A. This is your 7.17B. This is your 7.17C transition table for state assignment after applying the rules or guidelines. If you just see here, what was our table? If you all remember, the state assignment table where we had placed A, the first corner, B was here, E was here, if you all remember. Then BG we had as one combination, correct, which had 2 times. Then CF, then you had H and D. Now, based on this, this is done. You can see A is 0, 0, 0 because see, this is your 3 variable map because you have Q1, Q2 and Q3, 3 variable map. So this would be 0, 0, 0, 0, 1, 3, 2, 4, 5, 7, 6. Okay, now 0, 0, 0. Next is for 1, you have given 0, 0, 1. Where is C? C is 3. 3 is this 0, 1, 0. Okay, next D. D is, where is D placed? D is placed here. So which are adjacent? You have to see that table. I'm sorry here. One second. One second. I think we should write down this rule. Just a second. The value is wrong over there. So we will enter the value. Okay. Just, yeah. So this is your present state. This is your next state. This is your Q1, Q2, Q3. This would be next state is Q1 plus, Q2 plus, Q3 plus. Okay. By mistake, I have put the second table only there. Then this will be on input 0 and 1. Okay. On input 0 and 1. Then this would be your output Z or for input 0 and 1. Then this would be your 0, 0, 0, 0, 0, 1. Just go through this table, what we had done. What was that table? First one was A. Okay. Here it was E. Here it was B. Under B you had G. Okay. This is C. This is F. This is H and D. Okay. Now, A is 0. 0, 0, 0. Next one is adjacent one is B. B is 0, 0, 1. This is A. This is B. Then next one is C. C is what? 0, 1, 1. Because C is 3. This is 2. Correct? Next, A, B, C. Then for D, what is the value you see? D is what? This is 6, right? D is 6. How do you represent 6? 1, 1, 0. Then you have E. E is what? E is 4. 4 is 1, 0, 0. Then you have G. G is what? I'm sorry. F should come in order if you take. F is what? What is F? F is 7. E, F. Then G. G is what? G is 5. 5 is 1, 0, 1. Then F is, I'm sorry. Then you have your H. H is what? 2. 2 is 0, 1, 0. So this is how your table 7.17C is formed. And then write down the this one, next state. So from A, it is going to AB. AB. So what will be the value for AB? It will be 0, 0, 0, 0, 0, 1. Next, it is going to BC. BC means what? B is 0, 0, 1 and C is 0, 1, 1. Correct? Next one is from C, it is going to DE. What is the value of D? 1, 1, 0. E is 1, 0, 0. So this is written in this way. I think I need not repeat this. And the output remains the same. Write down the output for all the combinations. So this is how it is applied. Any doubts in this till now, whatever we have done? Please respond. Is any doubts? You have no doubts? Is it clear? Is it clear for everyone? If you have any doubts, you can ask. Okay, fine. If no doubts, it's good. Now, the next, this one is, after applying this, okay, how will you get the state assignment values? If you just see, this is your final table, what I wrote here, okay. This is your table. One, one, one. This is 101. Then this is 011. And this is 001. This is 110, 010, 001. And this is 011. If you have understood your this one next state, I'm just writing the values for the next state based on this value. That's all. See, from A it is going to AB. What is the value here? AB I've written here. From B it is going to BC. That value I've written. From C it is going to DE. So I've written the respective values, the new state assignment values. Earlier we used to do straight binary sequence, but if you see here, see, for A it is 000, for B it is 001, for C it is 011, for D it is 110. Okay, like this. This is our optimized state assignment values put onto the state map by applying the guidelines for state assignment. So this is how you have got. Now your output will remain the same. Okay, there are no changes for your output. 0 0 0 0 1 0 1 0. This is your output value. Now after applying the state assignment rules, you are supposed to check out the k-maps you are supposed to compute. I'll compute for one, so that you will know. For qa, qb, qc, you have to apply, that is for q1, q2 and q3. And then for the output z also you should do. So if you just see this here, okay, for if you just draw the k map, just a second. If you draw the k map for, say, q1 plus, for the next state q1 plus and, okay, so how you should take, see, look here, 0 0 0 0. So it will be a 4 variable map. It is not a 3 variable map. It is a 4 variable map because you are considering your x as 0, x as 1. Okay, so 0 0 0, that is, this is nothing but, if I take here q1, q2, q3 and x. Okay, so q1, q2, q3. So this is q1, q2, q3 and x. So 0 0 0 0, what is the value here? You have, this is your q1 plus, this is your q2 plus, this is your q3 plus. All these are for input 0. This is your q1 plus for input 1, q2 plus for input 1, for q3 plus for input 1. Like that you should go. So 0 0 0 0. If you consider the first column and start filling it. If you just see you have 0 0 0 0 0 0 0 0 1. What you have here? 0. So what are the values here? q1, q2, q3, x. 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. Now I'll take another color to mark so that it is clear. Now see, 0 0 0 0 for the first, this one, this is 0. So I'll mark 0 here. Next 0 0 0 1. 0 0 0 1. So the value here is 0. Next one is 0 0 1 0. It is 2. For 2 the value is 0. Then you have 0 0 1 1. For 3 the value is 0. Okay. Next one for 4. I'll just show for 1 this one. Then you can do for q2 plus, q3 plus and q4 plus. I mean output z. Then can you see here? So we are done with this. Next is 0 0 1 0. 2 we did, 3 we did. Then we have to go with 0 1 1 0. 0 1 1 0 is what? 0 1 1 0 is 6. So what is in place of 6? What is in place of 6? 0 1 1 0 is 6. So you have 1 in place of 6. So write down 1 in place of 6. Then 0 1 1 1. In 7 also you have 1. Write down 1. Then This is done. Then 1 1 0 0 1 1 0 0 is 12. In place of 12, you have 1. 0 0 0 1 0 1 1 0. We are done with. Okay. 1 1 0 0. Okay. Now 0 1 1 0 is 6. 7 we are done with. 1 1 0 0 1 1 0 1 1 1 0 1 is what? 13 is 1. Then 1 0 0 0 is 8. So in place of 8, you have a 0. Then 1 0 0 1 is 9. You have a 0 in place of that. Okay. Next one is we are done with that. 1 0 0 8 is done. Then 1 1 1 0 is 14. In 14, you have 1. Then 1 1 1 1, you have a 0. In 15, you have a 0. Okay. In 15, you have a 0. Then what is it? Triple 1 0 is done. Then 1 0 1 0 is 10. In 10, you have a 0. 10 is this. Put a 0. Then 8 9 10 11. No, this is 11. So 1 0 1 1 is 0. So put a 0 here. Then we have filled these things. Then next one is 0 1 0 0. So 0 1 0 0 is 4. In place of 4, we have a 0. So I'll mark it as sorry, this I have not written, I think, for H and this one. So for H, what is the value? It is triple 1. And for this, it is 101. I had missed this value. So here, what will you get? For 5, 5 you will get it as 0 1 0 1. For 5, it is 1. Okay. Sorry, for 4 also it is 1 only. 0 1 0 0. So this is 1. So now, if you try to make this one, you will have uh, one pair here. Okay. Then you will I'm sorry, one quad here, one more quad here, then one more quad here. Okay. So you will get some expression. What would be the expression? I think you all know how to write this expression. So Q1 plus equal to Q1 bar Q2 plus Q2 Q3 bar plus Q2 X bar. So after applying the state assignment rule, this is the expression what you have got. But if you just you can compare your expressions with your without applying your state assignment rules, what would be the impact? Okay. So this is how it is done. Like this you can do for Q2, Q2 plus, Q3 plus, and output Z. So see that expression. This is about your state assignment rules. And if you have no doubts, I think we will not waste the time. We will end it. Hope you all have no doubts. Is it clear? Okay, then. Thank you all. I will end the meeting. Shall I? Yeah, I will stop the recording.